All right. We talked about TCP in detail. Let's talk a little about UDP. Now remember, UDP's got a low overhead, and it doesn't really concern itself about reliability. It's expecting applications going up the OSI model to deal with that, whether it's asking for retransmission, whatever the case may be. So it's kind of like the best to be, if you've got an application that needs to be fast, like voice over IP, video conferencing and stuff, it doesn't establish a connection, it provides low overhead, so it's just perfect for what it's trying to do. Now, like TCP, UDP still has to reconfigure, still has to reassemble data, but so it's got all these datagrams that are sent. They take a wrong and the wrong. Now, since UDP does not track sequence numbers, UDP doesn't have a clue how to reorder their data. Therefore, UDP simply reassembles the data in the order that it was received and forwards it to the application. And the application will then decide what it wants to do and how it wants to proceed. So if you look at some of the processes and requests, like TCP, UDP still assigned, applications still assign well-known or registered port numbers. So you still have that port, that socket arrangement with IP address and with ports. But it just forwards the application over there and doesn't really care, because the server is listening for requests and that's all it's doing. It's trying to pay attention, so it's not waiting and trying to acknowledge receipt of information. It's just, hey, you're sending a DNS request, I'm listening, now I want to forward it over to, pass it on. So it does not have to do a lot more analysis. It just says, hey, I'm just basically listening for requests. Now, on the client side, there's a few things that go on. So one, you've got what happens when client is sending a DNS request, while in this case, client 2 is doing something totally different. It's asking for a radius request. But client 1 says, I'm sending a DNS request, or I'm sending an authentication request. Both of those are what? Those are all UDP, so all I'm doing is listening for the request. Now, the client requests the UDP server using the well-known port number, because it knows which application it's running, and then it assigns it a different source port, because what? I'm just running this application, so I've got to assign the destination port for what's going on, and then I'm going to use random port numbers for my source port. So I've got a well-known on the destination, a random on the source. What happens? When the server responds to UDP clients, it uses the source port from the request packet as the destination. So it pulls enough information out and says, hey, that's where I'm trying to go. That's my response. But it basically says that it's still got to make sure, I got to keep that, it's a two-way conversation basically. It still has to flip-flop the source and destination. But my responses, the server responds to UDP, to say, hey, I'm waiting for a server, I'm waiting for something else. But just know that it's similar to TCP, the source ports were reversed. So you can kind of see that same sequence of activity going on. So hopefully that gives you a rough, probably very rough information on the transport layer. Keep in mind TCP, UDP. TCP is a reliable network. UDP has lower overhead in trying to get information across as fast as possible. So hopefully this helps. And if you have any questions, let me know. Talk to you later.